Hello, welcome back. This is Logic Coding. Just a brief update. I did have an interview this morning for a coding session, and I can feel that I myself has improved a lot from like 2 months ago when I just started to grind in C++ on Leetcode. So yeah, I think practice really help. Leetcode is a great platform, and I'm going to continue to make videos just to make myself improve. So today we're going to look at a classical three-number sort problem, which is going to, unlike merge sort or heap sort or other sorting algorithm, where the best performance is going to be n log n. For this one, since we only have three colors, so we only have three numbers in our given array, we can actually achieve linear time complexity, and complexity is going to be linear, and the space complexity is actually going to be constant. Okay, so how can we first, let's tune back. What's the input and what's the output? So the input is a number of n objects colored only three colors. We have red, white, and blue. And we want to sort them in place. So just space complexity is going to be constant, so that the objects of the same color are adjacent with the colors in red, white, and blue. And we can represent those colors use integers, 0 red, 1 right, and 2 blue. And you may solve this problem without using the library sorting function. If we use sorting function, it's going to be very simple O log n. So for example, if we have three colors, which is randomly given, placed originally, and we want to output 0, 0, all the zeros to the front, all the 2's to the back, and all the zeros here. One pass using only constant extra space. So the optimal condition is going to be one pass and without any extra space. So whenever we are required to optimize space to a constant, the first thing we need to do is, can we use 2 pointers? In this case, can we use 3 pointers to help us traverse the nums and make a necessary adjustment? The answer is, of course, we can. So what we can do is, we have this number of arrays, and we will have a 3-pointer, P2, and the last pointer will be P3. What we can do is, P1 is going to make sure that all the zeros stay in the front, P3 is all the 2's stay to the back, and P2 will serve as both a runner node and somewhere in between. If I can make sure all the zeros stay in the front, all the 2's stay in the back, then what's left in the middle is going to be 1. Okay, so initially, my P1 and P2 will start at the beginning, and my P3 will start from the end. While I traverse, I don't need to return anything. While I traverse, I just do P2. If my P2 is equals to nums 0, which means I have encountered a 0, not nums 0, and then I need to put this 0 into my P1 place. P2 in nums P1. So for example, while I have a, for example, if here is 0, 0, I just swipe it, and then I have already made sure that my puts a 0 into my P1 place, and I need to increase my P1 pointer as well as my P2 pointer. Else if it can only equal to those values, P2 equals to 1. What I can do is, it's already in the middle, so I don't change P1, and P2 should move. I only can change P2 because I have already made sure that all the numbers before P2 are stay in the right place. else, so if it's equal to 2, then I need to swap my P2 with my P3, and I need to decrease my P3. Notice here we actually do not need to modify my P2. For example, in this case, I will start with here. So when 2 is actually starting from P3, I actually need to swap this 0 to 2. And what I can do is I move P3 back. And I don't change anything here because I'm not sure whether this 0 will satisfy. Maybe it's a 2, right? Or maybe it's a 1. So we cannot say anything. So we do not move anything. So now let's walk through this one. Now it's equal to P1. I swap with this and I increase them both. And then I increase them both. And then it's a 2. I swap this 1 and 2. And I just decrease my P3. And then if it's equal to 2, I increase my P2. Now they're equal. And then if it's equal to 1, then I don't need to do anything. But if it's equal to 2, basically I also don't need to do anything. So my end condition will be P2 is smaller or equal than P3. Let's try run the code. Submit it. Cool. This is kind of different than 2 pointers, but this like the idea of making use of just constant pointers to serve as a rounding point through the vector is very similar. I think the most important thing is to know it can only have 3 cases, either 0, 1, or 2, and under which case, besides swap, should we swap? And after swap, which pointers can I change? And it's always useful to just walk through the example. I think this is the optimal solution with linear time and constant space. Yeah, that's pretty much it. There are other methods that are not as optimal as this. So yeah, I'll just skip that and see you next time.